We're going to work on some area problems. We're going to do areas of polygons and areas of composite figures, which is when you put together more than one polygon. But before we do that, I want to talk about area because you probably have the formula memorized, right? Area of a rectangle is length times width. But have you ever stopped to think why you're multiplying length by width to get the area? So when we're measuring area, let me just draw a rectangle here. When we measure area, we're really just counting how many unit squares fit inside that space. And when I say unit squares, I mean if we're measuring inches, then the square is 1 inch by 1 inch. If we're measuring in feet, the square is 1 foot by 1 foot, right? Just depends on what we're measuring in. So if I were to break this up, I'm going to try to draw it straight. Let's just pretend these are squares, you guys. All right, and not rectangles like they appear to look like. Okay, so assuming these were all equally sized squares, if I asked you for the area of this rectangle, what I'm asking you is how many squares are there, right? Remember, they're all supposed to be equally sized squares. So you could look at this and you could say, okay, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But my guess is if I asked you to count these squares, you wouldn't do that. You would probably say, well, there's 8 in one row, right? There's 8 squares in one row, and there are 4 rows. So if I multiply 8 squares in each row times the number of rows, in this case 4, I would get 32. Now, we could sit here and count 32 squares, but it's quicker to just know how many are in each row and then how many rows we have, right? So that's why we multiply. Now, while we're here, let's talk about triangles because the triangle formula is similar, but it has something else. Instead of just multiplying the base times the height, we also divide by 2. We take half of it. Let me explain why. So I'm going to draw in a triangle here. Let's draw it like, actually, yeah, let's draw it like that. Okay, now it may not make sense like if I want to find the area of this triangle, right? So just this, I would have to do the base of the triangle times the height of the triangle and then divide by 2. So the base of my triangle is 8, the height of my triangle is 4, and then divide by 2. So that's going to be half of the number that I got before, right? But it doesn't necessarily look like half until you break it up a little further. Let me show you what I mean. If you look at just this part, right, this triangular piece in here, you can clearly see it goes from one diagonal to the other in this rectangle. It's definitely half of that rectangle that I circled. Then let's look at the other rectangle. That would be this part, right? And again, this yellow part that's inside the triangle, it goes from vertex to the opposite vertex. So it goes along the diagonal, cutting the rectangle in half along the diagonal. So that's also half. So if I'm taking half of the rectangle on this side and half of the rectangle on this side, I'm taking half of the whole thing. So every triangle, regardless of how it's drawn, every triangle is half the rectangle that surrounds it. That's why when we find the area of a triangle, we find the area of the rectangle that's surrounding it by doing base times height, and then we divide it by 2, we take half. Now you might see the formula written like this, 1/2 BH. I just think it's easier to look at like this, right? Base times height divided by 2. All right, so now I think we're ready to start. There are a few other formulas in here that I'm going to give you, but the two main ones that everything comes from are the rectangle, well, really the rectangle one, and then the triangle. All right. The area of this trapezoid. This is another formula where you're going to see 1/2 out front, so it'll look like this. 1/2 B1 plus B2 times H. But let me let you in on a little secret. This part of the formula, which looks like something really complicated, like, oh my gosh, we've got two B's and now they've got subscripts, like what is going on? All this is a math operation that you are actually very familiar and comfortable with. And that is taking the average of two numbers. Think about what we do if we take an average of two numbers. We add the numbers together, and then we divide the sum by 2. So what we're doing when we're finding the area of a trapezoid is really, we're doing, you could write the formula like this: average the bases and multiply by the height. That's what we're doing when we're finding area of a trapezoid. So let's look at our bases, right? I've got a small base down here, and I've got a longer base up here. How do I know that those are the bases? Because they're parallel. The bases of a trapezoid will always be parallel to each other. So I'm going to add them and then divide by 2. I'm going to take the average. If I do 7 plus 4, I get 11, and then 3, right? So my whole long base at the top is 11. My short base is 3. What do I get if I average 11 and 3? Well, 11 plus 3 is 14. 14 divided by 2 is 7. So this whole part, the part that looks so complicated and so confusing, it just means take an average. I averaged my bases and I got 7. So now all I have left to do is multiply by the height. And now this becomes a calculator problem, right? So now I'm going to do 7 times 6.2, and I get 43.4, and my units are very important here. Notice for length, my unit is meters. But remember what I said in the beginning, area is how many squares. So what I found here is that I could fit 43.4 squares that are 1 meter by 1 meter. And the way that we write that, instead of going like this, right? Because that's really what we found. But instead of doing that, just write meters. Oh, hold on a second, guys. We just write meters with a little 2. That means meters times meters, right? That's what we have when we have a square. We have a length and a width, and they're both 1 meter, right? All right, let's keep practicing with area. So in this figure, we have a parallelogram. And parallelograms have the same formula as rectangles, but let me show you why, right? I always want to show you why. You can probably already see this one a little bit. So if I take this parallelogram, right? I take this parallelogram and it's showing me the height right here, right? So imagine you were to cut this parallelogram right here, and then you take this part and you cut it off and you put it over here. Now the shape that I've got is a rectangle, right? If I cut that little triangle off the end and I move it to the other side, now I have a rectangle. So I can find the area of this rectangle by doing base times height, and it's going to be the same as the triangle. As the parallelogram, right? So that's what we're going to do. The area, we're going to do base times height, just the same way we would do for a rectangle. Now, the height is important. You don't measure the height on a diagonal. You always measure the height straight down, right? So the height is this 19 1/4. The base is my 22 1/2. So I'm going to do 22 1/2. I'm going to write it as a decimal. Everyone all right with that? Because then I can use my calculator for it. And then my height is 19.25. And let's see what that equals. 22.5 times 19.25 is 433.125. So if I was told, that's 1/8 by the way. So if I was told to round this to the nearest hundredth, I would round it to 433.13. And again, we're measuring area, so we're in square feet this time. Now, what you might see is since the measurements were originally given in mixed number form, the answer might be a mixed number. So 0.125. 0.125 is one of those fractions that I told you in the beginning of the year that you should know. It's a really common one. If you don't remember what it is, it's 1/8. But if you don't remember what it is or how to get it, then just make a fraction, 125 over 1,000, right? Because this goes to the tenths, hundredths, thousandths place. And, oh, actually, when you divide that, you're going to get 0.125. So that's not going to help. So how do we make this into 1/8? Well, we can still do this, right? Make your fraction 125 over 1,000. But instead of dividing like we're used to, because that's just going to get you back to the decimal, you would have to simplify. Both of these numbers are divisible by 25. They're both divisible by 5. They're both divisible by 125, right? Just keep simplifying until you can't simplify anymore, and you're going to get 1/8. All right, so another way we could write this would be 433 1/8 square feet. All right, there it is in mixed number form and in rounded decimal form and in exact decimal form. Okay, a rhombus. A rhombus is the same thing as a parallelogram, except it has one special feature. All the sides are the same. So that means that this side here that's not labeled is also 21, right? 21 centimeters. So I'm going to use the same formula that I used for the parallelogram because a rhombus is just a parallelogram where all the sides are the same. Kind of like a square is a rectangle where all the sides are the same, right? So I can use the same formula. My base is 21 because remember, all four sides are 21. And my height is 17.3. Now that brings me to another important concept. The height and the base always need to be perpendicular to each other. You know what perpendicular means? It means that they form a right angle, kind of like in your house where the wall meets the floor, right? That's perpendicular, like the letter L, like the letter T. Those are perpendicular, right? They meet at right angles. So that's another way you know that you're using the correct base and the correct height. They should be perpendicular to each other. All right, so now I do this in my calculator again. So I would do 21 times 17.3, and I get 363.3, and this is square centimeters. I know we write it centimeters squared, but the way that you say it is square centimeters. All right, let's do another one. Okay, so now we're getting to the composite figures, you guys. So I'm going to break this one up into two shapes. Some of you might have broken it up into three, but I'm going to put a line right here. And I'm going to look at, I've got a little triangle over on the right that I just cut off, but the rest of the shape is a trapezoid. Now, maybe you didn't see that. Maybe you were like, Mrs. Vargas, I just did the triangle and the rectangle. That's okay. You can do the triangle and the rectangle. I'm going to do the trapezoid, right? So that means that this unknown length up here is going to be 18 because that's what this one is, right? So my two bases for my trapezoid, this base is going to be 18 plus 4, which is 22. And this base down here is 18. So to find the area of my trapezoid, I'm going to average the bases and multiply that by the height. So to average my bases, I'm going to add them together. 22 plus 18 is 40. Divide by 2 is 20. And I'm going to multiply that by the height. Remember I said the height is always perpendicular to the base. So here's my little marking that shows perpendicular. So this is my height. So now I'm going to multiply by 12, and I get 240 square centimeters. Now that's just my trapezoid, right? Now I've still got this little triangle over here. So the base and the height, remember, are perpendicular. So here's my right angle right here, right? Which means this long line that I drew in is my base. I'm going to get that measurement from looking at the other side of the figure. So this has a base of 12 and a height of 3. It's kind of like you turn your head, it's on its side, right? So the area of my triangle is base times height, and then don't forget, every triangle is half a rectangle, so I divide by 2. So I get 12 times 3 divided by 2, and that's 36 divided by 2, which is 18 square centimeters. One more step, I've got to add the area of my trapezoid to the area of my triangle. So 240 plus 18 gives me 258, and that's square centimeters. All right, how are we feeling about that one? All right, I got a few more for you. Another composite figure. So again, I'm going to look at this whole top piece as a trapezoid, and I'm going to make my cut right here where they kind of already made it, right there. I'm going to cut off that triangle on the bottom. I'm going to look at the piece on top as a trapezoid. So for the area of my trapezoid, I'm going to average the bases, and I'll write it out this time, times my height. So when I average the bases, that means that I'm going to add them and then divide by 2. My top base, this one, is 4.6. My bottom base is these two added together, right? So 3.3 plus 3. So that's going to give me 6.3 for my bottom base. So when I average, I'm going to add 4.6 and 6.3, and then I'm going to divide by 2. Right? So that average is going to give me 4.6 plus 6.3 is 10.9, divided by 2 is 5.45. So that is 5.45, which I now have to multiply by the height. And the height of my trapezoid, remember that's perpendicular to the bases, right, is this number right here. So I'm going to do that times 3.15, and let's see what I get, times 5. That gives me 17.1675. If I round that, it would be 17.17, and this is square inches. Now that's only my trapezoid, so now let's do the triangle. So the triangle is base times height, and then don't forget, every triangle is half a rectangle. Okay, so I need the bases. So the bases, I have one base right here, right? This is going to be one base of my triangle, or that could be the height actually. And then this is what I need to know for the base. Now I don't have this length. It's not 6.3 because 6.3 is the whole thing, right? So how do I find it? Well, if the whole thing, let me just erase that just to make sure that I'm looking at the right thing. Just real quick, you guys. I just want to make sure that I'm reading that number correctly. Yeah, 6.3. So the whole side is 6.3, right? This whole side here is 6.3. But I know that this part of it is this, right? Is 3.15. So I'm going to do the whole height, 6.3, and I'm going to take away the 3.15, and that leaves me with 3.15 for this part. All right, so that's the base that I'm looking for. So the base of my triangle is 3.15 times the height of my triangle, which is 3, because remember, they're always perpendicular to each other. And then I will divide that by 2. So that's 3.15 times 3 equals, divide by 2 equals, and I get 4.725. Now, if I take my two numbers before I rounded and add those together, so plus 17.1675 equals, I get a grand total of 21.8925. If I'm told to round to the hundredths place, then I would look at the 9, because that's in the hundredths place, and decide if I leave it alone or if it gets rounded up. And it turns out I'll leave it alone. So I'm just gonna, just because I'm running out of room here, do that, right? So that would be my final answer, but then my units would be square inches. All right, I got 2 more for you. Another composite area shape. Now this time I'm gonna make it, it's really up to you how you cut these up, as long as you cut them up in a way that they are shapes that you know how to find the area of. So for example, I wouldn't do this, because then what is this? You know what I mean? We don't have a formula to find the area for that. So you want to make sure that you cut it up in a way that you know what the shapes are. So I would cut the little triangle off right there, right? And then I've got a triangle and a rectangle. So let's start with the triangle. You might be thinking that's the base, but remember, we just need the base and the height to be perpendicular to each other. The shapes are not always going to have the base on the bottom. That's important to remember. So as long as I see this right angle right here, I can say that 6 is my base and 7.5 is my height. Or I could even say that 7.5 is my base and 6 is my height. It doesn't matter because multiplication is commutative, right? The order doesn't matter. So to find the area of my triangle, I'm going to multiply base times height and then divide by 2, because every triangle is half a rectangle. And then that's going to be 6 times 7.5 divided by 2. I'm going to do a little shortcut here. I'm going to divide the 6 by 2 and get 3. So 3 times 7.5 is 22.5. That's just for my triangle. Now the rectangle is easy, right? It's very clear what my base and height are. Base is 16, height is 9. 16 times 9 is 144. I feel like I should have known that one. And then I'm going to add these two together, and I will, don't forget, I mean, you're going to use your calculator, but if you were doing this by hand, don't forget to line up the decimal points, right? So that would be 166.5, and we are measuring in square inches. All right, last one, you guys. Thank you for pushing through. I know this video was longer than most. Okay, so again, for this one, I would break it up into a trapezoid and a rectangle. So here's my trapezoid, on top. And that red line that I just drew in, I don't know the measurement of it, right? But I can find it because I can just look straight down and know that that measurement down on the bottom is going to be the same as it is at the top of the rectangle. So this must also be 16, right? So now for my trapezoid, I'm going to do the average of the bases times the height. So when I average my bases, I add them and divide by 2. So here's one of my bases, right, up here, right? This is 24. My other base is right here. So I have to add those two together, right? So 28 plus 16 is that long base on the bottom. So 28 plus 16 gives me 44 for my other base. And then remember, I'm taking an average. And then I'm going to multiply that by the height of my trapezoid, which is always perpendicular, right? That's what that little box means. It means that it's a right angle perpendicular to the base, so my height is 12. All right, let's do it. So 24 plus 44 is 68, right? Let me just make sure. It's late, and I'm a little tired. All right, divide by 2, and I get 34. So this is 34 times 12. So times 12 is 408. Now that's just the trapezoid, right? So I still need to do the rectangle. The rectangle, base times height. My base is 16. My height, I actually don't know, but I can find it again, right? Because I know from look, this 32 is the whole side. I don't want the whole side. I just want that bottom piece that's the height of my rectangle. But I know that if this is 12 over here, then this is also 12 over here, right? So if this is 12 and the whole thing is 32, then 32 minus the 12 at the top would give me 20 for the bottom piece, and that's the height of my rectangle. So that equals, let's see, 16 times 2 is 32, so that would be 320. And then I've got to add these two together. So 408 for my trapezoid, 320 for my rectangle gives me 728, and that is in square feet. All right, I know that was a lot. So as always, any questions, let me know so I can help. See you soon.